The first of the two crucial insights is that Einstein taught us that space and time are not separate entities, but rather they are two components of a bigger idea called space-time. I'll give you a helpful visual way to think about this in a moment, but for right now, just trust me on this. Then we need to combine that insight with the observation that everybody sees the speed of light to be the same, no matter how fast they're moving with respect to one another. Let's start with an analogy and then come back to relativity. To understand the analogy, you need to imagine a car driving on a huge flat surface. Further, you need to imagine that the car can only move at one speed, say 60 miles per hour, or, so the comments don't fill up with metric snobbery hate mail, 100 kilometers per hour. Now, let's put a couple of arrows on the screen to point out north and east. While we know the overall speed the car is going, we don't know how much of it is in the east direction and how much of it is in the north direction. So let's take a closer look at that. The car can move entirely in the eastward direction, which means that it has no motion in the northward direction. Or the car can move entirely northward and not at all eastward. Or we can live dangerously and move towards the northeast. In this case, we see that the car is moving in both the east and north directions, with neither direction getting all of the motion. So that's the core analogy, and hopefully it's very clear. Now, let's bring in relativity. In relativity, we don't have the east and north directions. Instead, we have space-time. Let's imagine that the horizontal direction is space and the vertical direction is time. So suppose that there is a single and fixed speed that we can travel through space-time. This happens to be true, so it's not a ridiculous supposition. We can therefore mix these ideas with our earlier analogy. An object can move vertically. In that case, they're not moving through space, and they're moving entirely through time. That's probably what you're doing right now. You're sitting and watching this video, so your position in space isn't changing. However, you are experiencing time. You aren't moving through space, but you're moving through time. On the other hand, what happens as you start moving through space? That's a fancy way to say that you gain some velocity. Well, we see here that what starts to happen is that as you begin to move through space, you move less through time. And eventually, when you move only through space, you don't move through time at all. And this is basically what relativity says. As you move faster and faster, your clocks slow down. And as you get very close to the speed of light, your clocks very nearly stop.